English department. Are we just doing a review basis?
I'm going to pass back your quizzes and take questions from those and take questions from the test review. So, if you have a minute, I can try to get you your quizzes back.
Yeah, I have some.
Your 5th period?
Yes.
Alright, I think I passed some of them back to you already the other day. Okay.
So.
But you don't have the most recent one. Just make sure you watch, you know where to find the class recording?
On the website?
Mm-hmm. Make sure you watch that because I talk about our test that's next class and like how much it's weighed in your grade and what you need to look at to prepare and all that kind of stuff. So.
Okay. Thank you.
Mm-hmm. And you can see what the other students asked as well. So.
Okay.
Table a little bit, Luke.
I said you want to push your table up a little bit. These bends get a little cramped.
I got a sticker.
Yes.
Absolutely. Yeah.
Which one went yesterday? The first page blank there, I can put it down in the hallway and you can pick it up right now. I'll have Chelsea go out the hallway and page blank. Or I can have you take it.
27.
That's gonna hurt. Monday, during class, while you're doing it. I have no preference.
I got a smiley face. Not this one.
Oh yeah, a little bit. Bullshit.
It's not warm.
That's not the right and it's so that I don't like disrupt something.
I mean, you can, but it needs to not be a desk where someone sits. That's the problem.
In that case, I'm
Yeah, that's.
crazy. It's great. And like, the biggest like the weather. It's very good. Like, it's really weird.
Good morning, FHS. Today is Wednesday, September 13th, 2023. Please join me in a minute of silence. Please join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
Sorry, sometimes the announcements don't come out through my speakers, so it's kind of hard to hear that. Okay, so on your desk you should have had back your 4.1, 4.2, and 4.3 quiz, unless I gave some of those back to you early. If I did give you some of those early for some reason, then you need to find those in your binder. And you're also going to need the number 18 test review. So, go ahead and get that out also. Okay, so this is a B week, so this is the last time I see you guys this week, but next class we have our first test of the year. So I need to give you some information about what you need to do to prepare for our test, what does it look like, how much it's going to weigh. And early in the year it's pretty easy to kind of predict based on where your grade's going to fall, because there's only going to be one test. And this is a really good opportunity for your grade. I would say for almost all students, test grades usually bring their overall grade up quite a bit. But if you remember when we looked at the syllabus on the first day of class, just like last year, all math classes are major category and minor category. So minor is 40% of your overall grade, major is 60% of your overall grade. So right now, what you can do, and I suggest you do this in the calculator just to give yourself a few examples. Right now, 40% of your grade comes from minor grades, which is everything we've done thus far. And I'm just going to use the class average. Right now the class average is about an 84, but you should type in exactly what your grade is if you know it. And then once you take the test on Monday, you're going to have, that's going to be your only major grade temporarily. So when we get to our second test, I'm not going to be able to give you such a hint like this, but this will be your first and only major grade temporarily. So you should look at, well, what happens if I get 100 on it? So if you had the class average of about 84, you could jump your grade up almost a full letter grade, almost 10 full percent. But you should also maybe throw in some hypotheticals. If you didn't study and you forgot more stuff on the test than you expected, I don't know what that would be for you compared to everybody else is different. But let's just say you made a 60 on the test, your 84 is going to drop down to 69.5. So you can throw in a few hypotheticals to know where your grade's going to land. And again, after we have a few tests in, that one test isn't going to be 60% of your grade, but early in the year, that's the way it's going to work out. And then the reason why, for most students, the test usually brings their grade up is, well, anytime you have to reassess on something, it's usually easier the second time because you've had more time to think about it, more time to digest it.
Teachers, pardon this brief interruption. I'll be making a few announcements this morning regarding today's Washington County College Fair. At this time, seniors in the PAC or the arena can move to the college fair at this time. We're encouraging everyone to walk clockwise when you get here. And also, Phase 2 seniors, you're dismissed now to come to the college fair. Please move to the door by the nurse's office and go straight into the arena that way. I'll be holding the door for you. All seniors, as I dismiss you, come to the arena, walk clockwise, and at 9:30, 9:35, you will need to move back to your first period class today. Okay? So at this time, seniors in the PAC, seniors in the arena, and seniors in Phase 2, please move to the arena for the college fair at this time and walk clockwise. Thank you.
Okay, so I don't know quite what that schedule is today, but if you are a senior and they do happen to call you out here, make sure that you know where to find the class recording so that you get all the same information. But okay, y'all have any questions about how to roughly configure what your grade's going to land at based on the test? You okay with that? Okay. But what I was saying before we got cut off here is most of the time the quizzes help pull up grades because our tests are very transparent. If you take your 4.1 quiz, all your major quizzes, if you took your 4.1 quiz, your 4.2 quiz, and your 4.3 quiz, if you were to rearrange those questions, staple those quizzes together, change the numbers, that is 90-95% of what your test will look like. So we don't really kind of hide that in any way. So part of why on review day, you can see on the agenda, most of this is set aside to ask questions because now that you've got your 4.1 quiz back in front of you, and again, as we go through the year, it doesn't take me so long to get them back to you, but at the beginning of the year, it's just waiting on schedule changes and all to work out. But you need to look at your 4.1 quiz. You need to make sure that you remember how to do the questions you got right, and you need to look at the questions that you missed. If you think you know why you missed it, you can see it was a careless mistake or something you didn't know at the time, but now you know it, then that's great. But if it's something that you knew and you forgot, or it never quite clicked with you and it would help to hear it again, then you will need to speak up and ask those questions. So we're going to go in order that we took them. So the first one I'm going to take questions from is 4.1. So take a minute, scan through your 4.1 quiz. See which ones you actually need help with and which ones you know why you missed. And if you've got 10 questions, that's fine. And if you have no questions, that's fine too. But again, basically everything on the 4.1 quiz, you should expect to pop up on the test. So it's now or never there.
Teachers, pardon this brief interruption. At this time, seniors, all seniors in Phase 3. Phase 3, move to the arena at this time. Walk clockwise when you get in, and move to the arena at this time. Thank you very much. Phase 3 seniors.
Okay, if that applies to anybody wanting to go to the college fair, that would be you. Okay, And I'm gonna drag my feet here for just a minute because I know you haven't had time to look these over yet. So let me wait just one more minute before I let you. Tell me what it is you want me to go back over. Okay, so for 4.1, if you do have some questions, let me know what they are, but you will also need to tell me which form you have. So we use several different forms, so it's going to be same skills, different numbers and such, but in the top left of 4.1, you can either see an A, B, or a C, so you'll need to tell me the question and the form. Yes, sir. Mathis.
Do question 9 on 4.9.
Well, we're only doing 4.1 right now. So Form A, number 9. Okay. So everybody needs to check and see if this is one you need help with, because I don't mind what questions you guys ask or how many of them you ask, but I'm not going to work to go over the same question twice. So don't be doing something else. Make sure that you don't need help with this one before you tune me out. But if this is not one that you need help with, then look at the rest of 4.1. If you're actually good with all of that, you can start looking at 4.2 to see what questions you want to ask, and or start looking at the test review to see what questions you want to ask. Okay, so question number, you said number 9?
Yes, sir.
Okay. Find the length of the arc if the radius is 10 inches and the central angle.
Teachers, pardon this brief interruption. At this time, all seniors, phase 2, 3, and 4, should be in the arena at this time. So seniors, phase 2, 3, and 4, please move to the arena at this time, and you'll return back around 9:30. Thank you very much.
Okay, so we've got the radius, we've got the central angle, and they're asking us for arc length. And in mathematics, arc length is S. So in this section, we gave you one formula that you have to memorize. We're not going to give it to you, but it's a pretty easy one to learn. It's going to be S equals R theta. So your answer to this question is going to be the radius, which was given to you, times the central angle, which was almost given to you. But you might think that the answer to this is 3,000 inches if you do it like this. Why did this not work? Because it's in degrees. The reason, again, my theory is the reason this formula is in the very first section is to show you that radians are not just different, they're needed sometimes. So you can't plug in 300, you have to change 300 into radians, which was a different thing that we did in this section. But we did allow a calculator. Okay, do you guys know how to reduce fractions in your calculator so you don't have to do them by hand when you have a calculator, because we don't always allow a calculator? Do you know how to reduce 300 over 180 quickly in your calculator? Okay, I'm seeing something.
Teachers, again, pardon this brief interruption. Seniors at this time should be moving to the arena for the college fair. All seniors at this time should be moving to the arena for today's college fair. Thank you.
Okay, so even if you can reduce fractions, this is still a good tip for like the ACT, because the ACT you always have a calculator. You can divide them, get a decimal, and then if you hit math, enter, you're asking your calculator to change it back to a fraction, and when it does that, it always changes it to the reduced form. So that is the same as 5 pi thirds. Now, sometimes I would have put pi in my calculator as well to get a decimal. The reason why I didn't do it in this problem is because of the directions. The directions didn't say round to the nearest thousandths. It said express your answer in terms of pi. What that means is pi is supposed to be part of your answer. So just carry it along, don't multiply it in. So for your form, it looks like you should have ended up with 100 pi third, and then the units would be inches. Yeah.
There's another way that you can do that. So if you do alpha and then do the y,
Uh-huh.
yeah, and then you press 1,
Okay.
it brings you to the fraction, and then you can just input your fraction, and it gives it reduced immediately.
It does? I thought this would change it to a decimal. Okay.
Yeah.
So what he said, just in case you think that's easier, alpha y equals option 1 is a nice way to type in fractions. This is for numerator over denominator. So I don't do this real often because I just use parentheses, but if you want it to look like a fraction in your calculator, and apparently if you type that in and hit enter this way, instead of it giving you a decimal, it just reduces your fraction. So anytime you have a calculator, I mean, it doesn't hurt for you to check your reducing, even if you do it by hand. And then something like the ACT, where you always have a calculator, that might speed you up a little bit. Okay, is that enough for 9? Okay. Now, of course, as you guys add some work to your notes or something, you probably should try to do that in a different color, or highlight what you're adding to it, or at least circle the question so that you remember which ones you need to go back and look at. If you got question 6 right and you remember how to do it, it doesn't make sense for you to study it and review it before Monday. Number 9, if you made a mistake, or you didn't know how to do it, or you had a careless mistake, or you think you forgot it, you should circle it, and you absolutely should look back at it. If it was on a quiz, there's a 95 to 99% chance this type of question will be on the test. So, okay. Somebody else have another one ready? Brandon? 1B?
Yes.
Okay, which form?
Question 10 for Form B.
Oh, Form B, question 10. Okay, so question 10 was the one that I believe tried to pull them all together. So, not just convert from degrees to radians, not just find arc length, not just convert degrees, minutes, and seconds into decimal degrees, but pulling all this together into a single question. So we've got the Earth. For your form, we said this was the radius of the Earth. Somewhere in here is Dallas. And the reason why this is in degrees, minutes, and seconds is latitude and longitude is one of the many things that we do. And then there's Omaha. Like that. Okay, so in a lot of ways, question 10 is a lot like question 9, where you're trying to find the distance, part of the distance around the circle, which is arc length, which means you should be using S equals R theta, just like question 9. And so your answer is going to come from the radius, which you have from the get-go, that's the easy part, times how big this central angle has to be. So how much this angle has to open up to get from here to here. So if this was at 40 and this was at 36, this angle would be 4 degrees because that's the difference between them. So what I really want to do is take this and subtract away this so I know how big this angle is. Now, in theory, you can do degrees, minutes, and seconds minus degrees, minutes, and seconds, but I don't recommend that you do it that way. So instead, I would suggest you change this to a decimal. So you needed this for other questions on the other page. 41 degrees, 17 minutes, and a minute is a 60th of a degree, and 59 seconds, and a second is a 3600th of a degree. So that is the location of Omaha as a decimal instead of degrees, minutes, and seconds. Now, you either need to keep up with all the decimals or ideally store this in for a variable. I'm storing it in for O for Omaha. Do the same thing with Dallas. It's got 32 full degrees, 50 minutes, and again, a minute is a 60th of a second of a degree, and 59 seconds. and seconds are a 3600th of a degree. So that is where Dallas is. So you either need to keep up with all decimals, do not round to 3 decimal places yet. Your final answer is going to be miles off from the final answer. Either keep up with all the decimals or do practice using the store button. I really suggest the store button because that helps you in other math things later on. So if this angle's at about 41 degrees and this angle's at about 33 degrees, then the difference between these is, I don't know, 7, 8 degrees or so. But since I have those stored in, I can subtract them. It looks like the difference between those would be 8.45. 8.45 degrees. And then the last catch of this question, just like question 10 or 9, this is a pretty easy formula to use, but this formula only works if this is in radians. So you have to know how to change this to radians. And you had other questions on your quiz about that, so we can go more in depth there. That's how many radians it is, times by the radius, central angle times radius, and it said round to the nearest mile. So it's closer to 619 miles. So it's about 0.147. Is that enough? Okay. So again, I'll be honest, I don't even remember if this is on the test, but if it's on the quiz, you should assume and be prepared for it. But what I always like about this question is we're supposed to know how to do this anyway. We need to know this has to be in radians. We have to know how to convert degrees to radians anyway. We need to know how to change degrees, minutes, and seconds to decimals anyway. So it really pulls together tons of different things from this one section all into one different question type for you. Okay, did somebody else have a question about 10 while it's still up? I should have said this earlier, but if you had Form A or Form C, your question 10 was probably the same type of question. If it wasn't, it's somewhere else on the quiz. And really the only difference is the numbers. So your approach should be the same. So sometimes you can still figure that out on your own, even if you had a different form. Okay, everybody's good with that? Okay, what else from 4.1? You need to have your questions. You also be ready to go if you have any more questions. I don't want to move on too quickly, but I'm also not going to spend more time on 4.1 than we need to in case you need more time on the others.
Question 8 on Form A.
8, Form A. Okay, this one says find the radian measure of the central angle. So this is what we're aiming for. If the radius is 11 centimeters and it intercepts an arc length of 5 centimeters. So just like question 9 and 10, arc length is S. And there's one formula that we gave you that ties together S, R, and theta. Same one we used in the last two questions. So I know S is 5 centimeters because they told me. I know the radius is 11 centimeters because they told me. And then the way you would solve this, some of you guys are going a little bit too quick here. Like you're doing this, setting this up correctly, and then you're just solving it too fast and saying like 11/5. To undo times, you should divide. The centimeters cancel out, and when all of your units cancel out, that is radians. Radians are the blank unit. So 5/11 should be your answer. Now, some of you guys put that in your calculator and got a decimal, but you should not be doing that. If the question doesn't ask you to round, you should not be rounding. Just leave it alone. This is less work, and it's a more accurate answer than typing it in and get a decimal. The only time you should be putting a decimal down is when it says, like question 7 says round to the nearest thousands. I expect to see 3 decimals there. Question 10 says round to the nearest mile. Question 2 said round to the nearest thousands. If it doesn't tell you to round, you should not be rounding. Okay, is that good enough for 8? Jackson? That's good enough for 8? Okay. Anybody else that wanted to ask about 8 before it's gone? Okay. Any others from 4.1? Okay, then let's move on. If we have more time at the end, I will give you another chance to speak up about 4.1 if I happen to move on too quickly. So next up would be 4.2. Let's sit down in the hall, please. If you would shut the door, and I'll come and get you when we're done with the quizzes. If you want to grab a chair or something, at least, you're welcome to. There's a rolly one back there that might be easier than picking one up, but. Okay, so 4.2 is 90% about unit circle. Unit circle questions, you have to know the angles in degrees and radians to know which location you're looking at. You have to be able to name the points because the points give you sine and cosine. With sine and cosine, you can divide them in a certain way to get tangent, and you can flip any of those three to get secant, cosecant, or cotangent. And so, again, that was the bulk of the questions. There was a couple even and odd type questions mixed in, but it's like 20 of the 25 points are all on unit circle. So as you find any 4.2 quiz questions, just go ahead and tell me what they are. You will also need to tell me which form you had.
You do number 7 on Form A.
Okay, 7 on Form A. Find the 6 trig functions at 2 pi over 3. Okay, so as I was saying, all unit circle questions, the first thing you have to do is know this location. So you can either straight up memorize all of the angles in degrees and radians, or the way that I do it is I memorize pi over 6 and I memorize pi over 4, because between these two I can calculate where everything else is going to land. So if here's where 1 pi over 6 is, I can add that distance again. Here's 2 pi over 6, but that reduces. Add it again to get to 3 pi over 6, which reduces. Add it again, you get to 4 pi over 6, which reduces to 2 pi over 3. So if you don't find the right spot, you're not going to get the right answers unless you make some other mistake and you just get real lucky that they balance out. The second step in every unit circle question is you need to know the point associated with this. So the way I draw these points, it's accurate enough that I can see it's a small x value to the left, and the smallest value is always 1/2, other than 0. And it's the big y value up, and the big value is square root of 3 over 2. So that's how I figured those out in the moment without having to memorize. But this is the key that unlocks all of your answers. So again, if you don't know where 2 pi over 3 is, you can expect to miss 6 questions that follow up there. If you don't know the point there, same problem. And then finally, with the point, cosine is the x value, sine is the y value, you can flip over secant or cosine to get secant. You can flip over sine to get cosecant. Now you do have to rationalize, just like when we did the bookwork. I told you if you don't check your answers, you're not going to know that this is not good enough. You have to multiply the top and the bottom by the square root of 3. And then tangent, this was a little bit harder at the time, but now you guys have done this probably 50 more times since then. Tangent is sine divided by cosine. So you actually have to work that out. Cancel out the 2's and you get negative square root of 3. If you think of that as a fraction over 1, you can flip it, and then that one has to be rationalized before you're finished. So there's where your 6 answers come from. if finding 2 pi over 3 or the points is where you're struggling at, again, really the best thing for you is just repetition. Get out a blank piece of paper, make a big circle on it, make yourself write how many degrees and radians are here and what the point is. Do it for all of the 3 points in each quadrant. And I don't know, if you can do it several times in a row without making a mistake, then you probably know the unit circle pretty well. And if you're making mistakes, then you probably need to practice more. Okay, the one other hint I'm going to give you on this, so we will allow a calculator on the first test. Sometimes it's part calculator, part no calculator. You will have to show work though. But the hint I tried to give you before this quiz, which would have helped you guys catch a lot of mistakes, but you know I can't make you do these things, is you could have checked some of this. So just because I said no decimal answers, you could have asked your calculator something like, hey, what is the sine of 2 pi over 3? And if you thought the answer was, I don't know, square root of 2 over 2, if you compared these decimals, you could see that your answer is not the same answer that the calculator is giving. And if nothing else, that tells you that you need to try something different. We got square root of 3 over 2. And the fact that these decimals are the same tells me that I probably did that correctly. Does that make sense? And then you could check some others as well. You could check our cosine answer. We got 2 pi over 3. We got -1/2, which is the same thing as what the calculator is given. This is also good to help you catch negative signs too. You thought it was 1/2, but it's actually -1/2. That's a big difference in trig. So try plugging a couple of them in and making sure that it's the same thing that you got. You can even do secant, cosecant, and cotangent. I know we haven't practiced using the calculator as much on those, but if you wanted to know secant, you would have to do 1 over cosine. And that's the answer we got, right? So I don't want this on your test, just like you didn't do it on your quiz, just like you didn't do it in your homework, just like the back of the book didn't look like that. But if you're smart and you're paying attention, then you can use that as a backup to check some of those answers. All right, Colin, was that enough for that, or did you have something specific?
What?
Did you have something specific?
Oh, no.
Okay, that's enough? Okay. Anybody else that wanted to ask about this one? You may not have had this exact same question if you had the other forms. You may have had a different angle, but... Okay, what else from 4.2 then?
Can we talk about question 3 on form B?
Okay, so this was one of the few points on this that was not unit circle. So they tell you some angle t, which we don't even know this angle because I'm not familiar with this ratio, but some angle t has a sine of -2/7, and somehow we are supposed to know the sine of -t. And then once we know that, we can flip it over and get the cosecant of -t, because these are just reciprocals. They're talking about the same angle. You should be able to do this 2 different ways. One is you should know that this is an odd function, and what it means to be an odd function is that if you plug in a positive angle like t versus a negative angle like -t, the only way they're going to be equal is if you multiply 1 by negative. So if this is -2/7, this one has to be +2/7. And then again, if you have this one, you can flip it over. They're talking about the same angle. They're reciprocal functions. So 2 over 7 becomes 7 over 2. Or you could try to visualize it. So to visualize it, I would say you would try to draw a picture. You would say, I don't know how big t is, but I'm going to draw something so I can try to visualize angle t. Sine is the y values on the unit circle. and they were wanting me to find the sign at negative t. Well, if this is how much of a turn is positive t, that same amount of turn in the other direction is negative t. So if this guy was going up, well, okay, this is not a great picture. I should do it. This is why I don't like to rely solely on the pictures. But for angle t to have a negative sign, t would have to be like, thank you. T would have to be like all the way down here somewhere so that it had a negative. Okay, so maybe that's what t looks like. So negative t would be the exact same amount of a turn, but in the opposite direction. So all the way around, 2 quadrants plus a little bit more. That's what negative t is going to look like. So if this guy is going down negative 7 halves, I can see now that this point up here is going up. Scratch it. I'm sorry, it was going down 2/7. This one's going up the same amount, so it was going up 2/7. So his sign is 2/7. So I'm not saying that the visual to me is harder than just knowing the even and odd stuff, because you're supposed to know the even and odd stuff for other things anyway. Basically, you keep the sign the same or you change it. If it's an even function, it stays the same. If it's an odd function, you multiply by -1. But it's still good for you to know multiple paths here, because on the test, if you have extra time, maybe you get this answer by doing this. You could also go back if you had more time and try to visualize it and make sure you got the same answer. So. Okay, let's move on from 4.2. Again, if I'm moving on too quickly, there would hopefully will be a few minutes at the end of class that you can ask for another. You should also have the basic trig identities quiz, but that was just straight up memorization. So some of that helped us in some other stuff, but mainly the trig proofs. I'm not going to take questions from that because you should have those filled out in your notes if you need to look those up. Again, those are the basics that we all memorized. So that would leave 4.3. So on the front, we had a couple SOHCAHTOA questions, finding side lengths, SOHCAHTOA finding an angle. More SOHCAHTOA on the back, and then 2 trig proofs. So as you find questions you would like me to discuss over 4.3, tell me what form and what number. Yeah.
For how do you do 7B?
7B. Okay, and it's not the exact same number, but I think both forms that we used on this one had this as a question to do, so I think both of you had to do it. Okay, so looking at this left side, I don't see any algebra that jumps out at me. I don't see anything that needs to be FOILed or factored or anything else. So if I don't know anything else to start, and again, these were 3 points each, so I gave you 1 point if you even considered switching this to sines and cosines, and switching this to sines and cosines. That's the tip I gave you that I said will always work, but if you jump into that all the time, you're going to make some easy questions way harder than they have to be. But I gave you 1 point if it looks like you considered that. Then at some point, I realize you're not going to think of it as quickly as me because I've done more of these, but there were several questions that we practiced where this side has 2 fractions, 2 terms. This side has 1 big fraction, 1 term. So if I don't have an identity that's going to push these together into 1 big term, probably the next best thing is to add these with the common denominator. So right now my left fraction is cosine over sine. My right fraction is sine over cosine. And so to get a common denominator, this guy has a sine and this guy has a cosine. This guy needs a sine. This guy needs a cosine. when you're fixing these to have a common denominator, you can't just multiply the denominator by sign. You're making this fraction smaller if you do that. You have to multiply the top and the bottom by the same thing. So like you're multiplying by 1. And multiplying by 1 doesn't change the size of it or anything. And the whole purpose of us getting a common denominator is now we can squish this together over this common denominator. So I've got cosine squared plus sine squared. And if you're seeing a Pythagorean identity somewhere in your question, that's probably a good hint that you're on the right track. Sine squared plus cosine squared is the first Pythagorean identity. You should recognize that as 1. And then finally, you can pair up 1 over cosine to get secant times 1 over sine to get cosecant. And now the left side says the same thing as the right side. So I've realized the last few days that for some of you guys, these, I don't know what it was, the COVID year when you first learned fractions or whatever, but I realize adding and subtracting fractions is difficult for some of you guys. But if you're serious about doing calculus next year, you've got to be able to do things like that. I teach some of the AB classes, and like they have to, well, I'll spare you not looking up the question for you to look at, but they have to do that all the time, and we can review it for just a moment. But if you're spending your homework time trying to remember how to add and subtract fractions, that's less time where you're actually learning the new calculus, and that doesn't pan out well. So it's fine if it's not easy for you, but you've got to put in the work and get to where you need to be if you're really going to take calculus next year. Anyway, that's how I would do that one. I don't think there's a more efficient way. So I think there are some people that probably kind of went around in circles and then still figured it out, and that's fine. But as long as it worked.
Can you do question 1 on Form A?
1 on Form A. Okay, one thing I will say about this one for you guys is, and I don't know what it is about the wording, but we give you an angle at angle ABC. It asks for the width of the river B, lowercase b. Side B is always opposite angle B. And then based on the description, this is supposed to be 110 feet. Now, I guess I can kind of see where you may have labeled your triangle differently if you thought that information was saying other parts. Well, if you showed your work, which a lot of you guys did, you said, I thought it was actually sine or something, and if I could follow your work and you worked it correctly, but you set it up wrong, then you only lost 1 point. If you set it up incorrectly, you went to your calculator, you typed it in your calculator, and then you just wrote out an answer and your answer is wrong, I can't give you any partial credit because I don't see what your mistake is. You guys need to be writing that stuff down. But this is, anytime you're trying to find the side or angle of a right triangle and you don't have enough information for Pythagorean theorem, it's going to be SOHCAHTOA. You were trying to find the opposite length when you know the adjacent length, so that has to be tangent. Tangent's the only one that's going to let you pair up the opposite length over the adjacent length. And then these can solve one of 2 ways. Your variable can be in the numerator or it can be in the denominator, so make sure that you're aware of that. But this one, you needed to undo divided by 100 by undo dividing by 110 by multiplying both sides by 110, and it looks like it should come from this, and it said round to the nearest thousandths, so I put that in my calculator and rounded to 3 decimal places. Okay, you saw what you needed there? Okay. Anybody else want to ask about question 1 while it's still up there? I would say the setting up on question 2, well, I'm a little more understanding why you may have set up number 1 wrong. By the way, you guys can always ask those questions during quiz time. I can't help you with the math, and I can't explain how to use your calculator or anything like that. But if it's something about the directions, you can always double check. We can work question 2 if y'all need to, but the one that really, it's weird to me how y'all set up number 2. Most people put 5 here, and then the ramp they put here. A ramp is the thing that goes up, like if nobody's measuring a ramp length by the horizontal distance under the ramp. Nobody cares about that. This 32 feet is supposed to be up here. That's the ramp. Okay, what else from 4.3 can I help with?
Can you do 3 on
3A. Okay, not much different than number 1. It's going to be SOHCAHTOA. We give you an angle. It's a little easier to know what side you're trying to find and what side you know the length of. So if I'm going to work from this angle, I know the opposite length, so not cosine, and I want the hypotenuse length, so not tangent. It's got to be sine. Sine's the only one that's going to put opposite over hypotenuse. Now this was what I was saying about question 1. Just because you got question 1 right, you could still miss question 3, because if your variable's in your denominator, this solves differently. I know these two just swap places, so I can take this shortcut. If you don't want to memorize that, that is fine, but algebraically you need to multiply both sides by x so that you don't have a fraction, and then undo times by the sine of 20 degrees by dividing by the sine of 20 degrees. And that one said round to the nearest thousandths, so I threw that in my calculator and rounded to 3 decimal places. Anything more specific there?
No, I've got you.
Anybody else that wanted to ask about 3, have something more specific while it's up there? Yeah.
Can you say an A?
Okay, does anyone need any more help with this one first? Okay. 7 from Form A. I'm not sure, and both forms did have this one, just different number. I want to say this exact question was one of your practice questions on one of your worksheets, but I could be wrong. It might be a slightly different version. Okay, so I'm looking at this and I'm trying to think about how to start it. It doesn't look like it needs to be factored or FOILed or add my fractions. I don't really see any algebra to start off. So at some point I've got to move forward. So I'm going to change everything into sines and cosines. So sine is already in terms of sines, cosine's already in terms of cosines, but cotangent is cosine over sine. And since these 3 are just being multiplied by each other, you can cancel out this one with this one. Times sine divided by sine cancels out. And you're left with 1 minus cosine times cosine. And now this is a version of the first Pythagorean identity. Now, luckily you guys did pretty good at not doing this, but most years there's always a handful of students that stop, and this is all they give me. I can't give you all 3 points if you stop here. It looks like you got stuck and you didn't know what to do. You need to go one more step and say that stuff is sine squared. The last step needs to be the exact same thing on the left and right. So, know your Pythagorean identities. Those 3 come up a lot, and consider changing everything into sines and cosines, like part B. Okay, anybody else want to ask about this one? Okay, moving along then. What else? 4.3. Again, I don't mind what questions you have, just keep them coming, please.
Can you talk about number 4 on 4B?
4 on B. Okay. I would say there's really one big hurdle to this question. I'd think most people are going to get part A correct. If you know your reciprocals, sine's the reciprocal of cosecant. So if this is 4, this is 1 over 4. But the key to these other ones, which is why it's important that you guys review the stuff I ask you to review. Part of your homework, I asked you to please look back at your homework, because this came up in your homework on questions 15, question 17, question 30, and 31, I think, where you could only get part of your answers, but to get the rest, you needed to make a picture. So, like the first 3 homework questions, they did the picture for you, and then the next couple, you needed to make them. If sine is 1/4, label your opposite as 1 and your hypotenuse as 4. Then you can do Pythagorean theorem to find this side. You get the square root of 15. I think a couple people said the square root of 17. Just be careful that you're not going too fast through the arithmetic. And then now SOHCAHTOA. You want cosine, you need to pair up adjacent over hypotenuse. And if you want tangent, you need to pair up opposite over adjacent. And you need to rationalize that. Rationalizing is understood that you need to do that. Just like you wouldn't leave a fraction 2 over 4, you shouldn't leave a fraction unrationalized. Yes?
Before, I don't think it was cosecant, I think it was secant.
Oh, I'm sorry. Was it Form B? Did you need Form B or Form A, Jackson?
Form B.
Okay. Yeah, Form B it was cosecant. Form A it was secant.
Yeah.
He had a different form than you, that's why. But similar thought. Do you need to go over that one too? Is that what you're asking?
No.
Okay.
That was completely fine on this one.
So I think if you got just part A right and not B and C, it's probably because you didn't think to make a picture out of this. And honestly, I get it, I understand, but that's why you guys have to review that stuff. I know we give you a practice quiz sometimes, but I mentioned that looking at the bookwork, 5, 7, and 11 were the same type of question, so I told you there'd probably be one like that on the quiz. 15, 17, 30, and 31 were the same type of question, so they're probably going to be on the quiz, and that was this one. So if you don't look back at that stuff even for a few minutes, then you run the risk of not knowing how to start them. You need to give yourself that kind of reminder.
Could you solve that with like the Pythagorean identities? Like, could you get like cosecant by plugging in the sine in the first Pythagorean identity?
You could. So like, because this, and that's a great question. Thank you for asking. Because this is always true, if you know sine is 1/4, 1/4 squared is 1/16. So yeah, you could go about solving that, and then you could get cosine, and then you could, well, it just asks for cosine, but yes, you could do that. However, the problem with this is, like, so let's say if we finish solving this, we would subtract this over, you would get 1 minus 1/16, which you'd have to get a common denominator and figure out that that becomes 15/16. You have to unsquare both sides by square rooting both sides. When you square root both sides, you need to do plus or minus. You need to realize why you don't need the minus here, because this is going to be a length. The square root of a fraction is the same thing as the square root of the numerator over the square root of the denominator. So you can see I got the same thing. So even though yes, it's possible, you're going to just have different challenges. I really feel like setting up the triangle and just using SOHCAHTOA is the safer bet. You should have practiced this multiple times. You probably didn't practice this any, but yes, in theory that also works. Actually, the further along we get in the trig, the more connections you guys see. There's more choices on how you want to work things. So, Okay, let me reset here. So I told you guys I'd give you one more chance if I moved on too quickly, so make sure there's nothing else from 4.1, 4.2, or 4.3. And then I will give you a chance to ask about your test review.
How many pages is the test review? Because I was looking at it on Google Classroom.
3.
It's 3 pages. I think.
Well,
I don't think.
If you count this as 2. They're still over there. And number 18, if you need a copy.
I think my page just got cut off because it skips 17 and 18. It also skips 5.
Yeah, mine's.
I think the numbering just got weird.
Yeah.
I think Word just auto-corrected is why there's not a number 5. The reason why there's not a 17 or 18 is because we used to also do linear speed and angular speed in section 4.1, and we don't make y'all do that anymore. So we took that off the review and we just didn't change the numbering, so that's why. Okay, I am ready for, I'm sorry. Was there anything else from any of the quizzes? By far your single best resource is your 3 quizzes. Secondly would be test review, but making sure you know all of your mistakes from 4.1, 4.2, and 4.3 quiz is the most important. Yeah, Piper?
Can you do number 2 on for
4.3, number 2, what form? A. Okay, this was the ramp question. So the ramp was 32 feet, and over 32 feet, it is 5 feet off the ground. And from that, we're supposed to be able to figure out how big angle A is. Same thing I was saying about question 1 earlier. If you put 32 down here, but you wrote out your work where I could see your mistake, if I could see that was your only mistake, I still gave you 3 of the 4 points. But if you did some of it in your calculator, some of it in your head, and you're not writing it down, then I can't give you partial credit for what I don't see. But when I look at this from A, I know opposite and I know hypotenuse. So SOHCAHTOA doesn't just find side lengths like questions 1 and 3, it also finds angles. And if you know opposite and hypotenuse, that needs to be a sine equation. So the first step isn't any different. You say sine, when I'm looking at this angle, is equal to opposite over hypotenuse. But then you need to know how to change this from sine A equals to just A equals. And that is by using the second sine, the inverse piece in your calculator. If you're trying to find side lengths, you use regular sine, cosine, tangent. If you're trying to find angles, it's inverse sine, inverse cosine, inverse tangent. And so this says to the nearest thousandths of a degree. So you would need your calculator to be in degree mode. And then when you type in inverse sine of opposite over hypotenuse, right when I hit enter, my calculator understands that I'm asking it how big is an angle if its opposite was 5 in length and its hypotenuse was 32 in length. And it knows that because I'm picking sine, and it knows I'm asking about an angle because I'm doing inverse, and it's going to give me my answer in degree because I'm in degree. So 8.989. Correct. Side lengths, the regular trig functions. We'll do a whole section on inverses in a while, and it's probably the second hardest thing we do all semester. I think the hardest thing we do are the trig proofs. But so we'll go more in depth about why it works that way, but right now all you need to know is that inverse is for finding angles. And it's fairly proportional. This quiz only had one question like that, so the test isn't going to just all of a sudden have 5 questions like that. But if there's one of these on the quiz, you need to make sure you look over it and remember it for the test. Okay, is that enough there, Piper? So actually, this is, I don't know that you guys care, but one of my high school friends that I still keep in contact with is probably like 8 years ago. He bought a really like small beat up house that he was going to fix up, and he moved it onto a plot of land and he was going to rent it out. And one of the things, like the requirements to the building codes before he could rent it out, is like the what do you call that right before the door, like the
Porch, patio?
well, I'm just thinking like this, like the couple feet right in front.
Like the metal plate.
No, just like where people put their welcome mats. Anyway, you know what I'm talking about. Yeah, the doorstep. I think that's what I'm talking about. If it's not at a steep enough angle so that when it rains you don't have water trying to get in your house, then you can't legally like rent it out and stuff. So this is exactly what he was doing. He had to calculate, and he didn't remember how to do this. This is why he texted me about it. He had to figure out, I can't change this to get up to the door, but I can change how far back this starts, and he knew what angle he had to get at before the city was going to let him rent out. So just an example of where you might need this someday. I don't know what the angle was that he had to meet, but it was a thing. Okay, others? Still on quizzes? Anything from any of the quizzes? Yes, Lucas.
Can you do number 5 on 4.38?
4.3, number 5. Okay, so this one gave us 2 pieces of information. It said secant is 5 and cosecant is 5 square root of 6 over 12. And from that, we should be able to figure out what tangent is of the same angle. The cosecant of 90 degrees minus theta. The sine and the cosine. Now, you guys are probably going to disagree with me, but the easiest of these questions is this one right here. This is one of the basic identities that we ask you to memorize. This is one of the cofunctions. What does the cosecant of 90 minus theta, what is it always the same thing as? See, if you don't know that, you're never going to get this one right. Not cosine. It's secant. So the answer was right there. I didn't have to do anything but other than to know that that is always the same thing as secant. I'd say the second easiest is probably part D. If you have secant, you can flip it over to get cosine. Those are reciprocals. And then you've got options. So I've got cosecant. I could flip it over and simplify to get sine. That's a possibility. And or I could take this and, like question 4, I could try to make a picture out of it. If cosine's 1/5, I could label the adjacent as 1 and the hypotenuse as 5. And then do Pythagorean theorem over here. This becomes the square root of 24, which is 2 square root of 6. And if you go the picture route, then sine is opposite over hypotenuse, and tangent is opposite over adjacent. If you don't go the picture route, you can take cosecant and flip it over, but then you have to simplify this. So you would have to rationalize the denominator, and reduce your fraction because it said simplify. And you still get 2 square root of 6 over 5. And then if you didn't have a picture, the only way you would get tangent is to take your sine divided by cosine. And you would still get 2 square root of 6. So 2 ways to go about that. But I guess if I tried to sum up question 4 and question 5 in just a couple words, it is you need to make a picture. If you guys make a picture with the information you have, finding the rest of the information is significantly easier. No picture is hard. You can't visualize anything, so it's hard to, sometimes it's hard to know how to move forward. Okay, others from test review, or I'm sorry, quizzes. Okay, what about test review then? So, questions 1 through 4 and 19, hopefully you did before the 4.3 quiz. Again, I guess that wasn't required because I didn't ask you to turn it in. But if you had taken my advice, question 1 sure looks a lot like 4 and 5 you guys asked about. Or actually, 1 looks like 4 on your quiz, number 2 looks a lot like 5 on your quiz. So, if you had thought about those things again, that might have been helpful. Yeah, what you got?
Could you help me out with number 4A and B on the review?
Okay, so for part A, for all of these trig proofs, again, you have to know all the basics, which is why we tried to give you guys 20 points on that quiz to just memorize them early so that you weren't trying to memorize them as you were trying to learn how to do these. But anytime you have these, my suggestion is to write them all 3 out once carefully at the top of your page. Sine squared plus cosine squared is 1. Divide everything by sine squared. Divide everything by cosine squared. Okay, and I did this because I'm looking at this middle one and it looks a lot like this one on the right. So my guess is that I'm probably going to use this in this question at some point. Okay, you've got to divide these in some way. So you could change this into sines and cosines. You could change this into sines and cosines. I think one mistake that you guys make that makes it harder to see what to do is you write it like this. And this is correct. There's cotangent in terms of sines and cosines and tangent in terms of sines and cosines. But this is called the vertical format, and it's kind of hard for you to see what to do from here. So what I would recommend is that if you have it like this, change it to the horizontal format. A fraction bar just means division. And typically, you guys are a little more comfortable moving forward from this. Dividing a fraction is the same as multiplying by the reciprocal. You can multiply these together to get negative cosine squared over sine squared. Cosine squared over sine squared would be cotangent squared. Okay, and again, I suspected I needed to use the second Pythagorean identity, so now I'm kind of eyeballing this. I need to solve it for negative cosecant squared. So if I subtract this over to make it negative, I need to subtract this over. So negative cosecant move this over so it's negative, or sorry, negative cotangent, and then subtract this over. It looks like negative cotangent squared is the same thing as 1 minus cosecant squared. And since that's a basic one that we have memorized, I don't have to prove why that's true. I just need to recognize it and make the correct substitution there. Is that okay? Okay, also, so this is a long way here, by the way. There was a much quicker way where you could have skipped all of this and gone straight to here. Remember, dividing by something is the same as multiplying by its reciprocal. So dividing by tangent is really the same as multiplying by cotangent. So negative cotangent times cotangent ends up being negative cotangent squared. So if you catch that and you're paying attention there, you can not have to change them into sines and cosines and figure out what it happens when you divide those fractions and change it into multiplication and then changing it to cotangent. You can skip a lot of steps, but again, sometimes you will catch it and sometimes you won't. Okay, is that enough for A? Okay, and then B. Okay, so just at, I have not worked this question this year, but with a 2-second glance, it sure looks like this wants to be FOILed. So if I FOIL these two things together, we're going to get a secant squared, a minus secant tangent, a plus secant tangent, and a minus tangent squared. These are equal but opposites, so they add up to 0. And then I think this might be one of our Pythagorean identities. So I would glance at the top of my page where I had them written down. Looks like this guy. If I subtract the tangent squared over, that would leave over a 1. So apparently secant squared minus tangent squared is 1. So since that's a basic identity, I don't have to prove why that's 1. I just have to recognize that it's equal to 1, and then you can be done. So FOIL, combine like terms, Pythagorean identities. I believe our test has 2 trig proofs. So like I said, it's usually pretty proportional with the quizzes. If the quizzes only have 2, the test isn't just all of a sudden going to have 10 of them. But you should expect a couple at least. Yeah.
Whenever I didn't recognize that secant squared minus tangent squared equals 1.
Okay.
So I added tangent squared to the other side.
You can't do that because you're not solving an equation.
Okay.
You can't add, subtract, multiply, or divide it to the other side of the equation.
Okay.
Ever. One side needs to be left alone. The only thing that you could do, and I'll just do the fast version to spare you here, if you don't recognize this as the one of your Pythagorean identities that you're supposed to memorize, the only way you could still get the points is change this into sines and cosines, change this into sines and cosines, add your fractions. Luckily, they're already a common denominator, so it's not terrible. Recognize that this is the form of the first Pythagorean identity, and it's cosine squared, and then cosine squared divided by cosine squared would be 1, because anything divided by itself is 1. So you can still get all of that, but this is what I'm saying. If it's a basic identity, you don't have to prove that. But if you don't recognize it or catch it, then that's the hoops you got to jump through. But you cannot just add something to the other side. But do let me ask, when you said that you added something to the other side, what did you add to the other side?
Tangent squared.
So, like that?
Yeah.
Okay, how was that any better for you?
I don't know, at the time I saw secant squared and
because of this?
Yeah.
Okay, so I use the exact same identity, I just did it in a different way. Whereas you wanted to add this over so that you could say this was secant, this stuff is secant squared, and this stuff is secant squared. I just rearranged it and said all of that's equal to 1. So you were looking at the right identity, but don't add something to the other side. You can do that out to the side to figure out what secant squared minus tangent squared is equal to, so that you can figure out that that's equal to 1. But don't add it over and then say, okay, well now it's the identity. Okay, well y'all finish looking, one more chance at your test review. Okay. What else from test review? Okay. Then you guys still have about, I don't know, 15, 20 minutes, something like that. So if you do see something, you're welcome to speak up. But you need to make sure you're prepared for the test. I talked about how much it could impact your grade for the good or for the bad. Hopefully for the good. You should expect your test to look like your 4-1, 4-2, and 4-3 quizzes, stapled together, different numbers, questions rearranged, but same skills. That should be about 95% of your test. So make sure that you're comfortable with all the quizzes first, and then your test review. I will ask for your test review for some homework points, and I will open that up in Google Classroom right now so that you guys can turn it in now if you'd like to. And then I got one more announcement I need to give you, a reminder about late work and stuff. Okay, so the test review is in Google Classroom now, so please turn that in sometime before next class. If you have it completely finished right now, which you should because that was your homework, I would recommend you turn it in now so you don't forget about it. But one other thing that you guys need to do before next class and our test is late work and complete work. So I talked about late work the first day of school, but I know you guys have had a lot of teachers give you that kind of information at first and you don't really remember. But I do take late work, but only up until that unit test. So I'm talking about it again because Monday is our unit test. So if there was anything from this first unit that you didn't do or you didn't turn in and you have a 0 for, you can still do it. It has to be 100% complete. You still need to check your answers. You need to still follow through with fidelity like everybody else did. And you can get half of your points back. So if you didn't turn it in the first time and it's a 0, you can get half those points back. Most assignments are out of 10 points, so you could get 5 points back. But there's no limit on that. If there's 4 assignments you didn't turn in, there's 4 assignments you can turn in for late credit. But I will not take it after we start the test on Monday. And you can turn those in the Google Classroom. The other thing that I think sometimes students don't realize is that if you got half credit because you turned in something incomplete, you can finish it, which is usually just a little bit more work. And if I get it turned back in before the test, you can get half of your points back. So if you turned it in incomplete, you got half credit. But if you finish it and turn it in before we start the test, you can get half of those points back. So you could end up with like a 7.5 out of 10 instead of a 5 out of 10. But I have no wiggle room. I'm not willing to take stuff past the test. So You can turn it in before. You can turn it in this weekend. You can turn it in Google Classroom now. But once we start the test on Monday, no more homework grades from Unit 1. So I'm just emphasizing that because if that applies to you, if you don't know if it applies to you, you need to check Grade Gear. And if it does apply to you, then you need to make that part of your work. And of course, going back and finishing those things or doing those assignments can also pay off by helping you with your test. Okay, any questions about the late work, incomplete work? Any questions about the grading of the test? How much it's going to count towards your grade at first? Any questions about what it is you should look over to prepare for your test? You got one? Okay. If y'all see any more math questions, you still got about 10 minutes, so I'll still be happy to help you, but you got to speak up and tell me. Check.
Remember like some the ones for 16, the bond statements.
Yeah. Number 16, explain why these are not true. Okay, which ones were you struggling with? A, G, and what?
D.
And D? Okay, so A says that the sine of an angle is 5.4. Well, if we think about the unit circle, what is the sine value at 0 radians? Sine's the y.
Just 2 by 0.
No, I'm saying what is the sine ratio at 0?
1, 0.
I'm sorry, I couldn't hear you.
1, 0.
Okay, but I'm just interested in sine. So sine is 0.
Yeah, 0.
Your angle gets a little bit bigger. Sine increases up to what? Okay, you keep going. Sine gets back to 0. You keep going. Sine gets down as far as. So the only way for you to answer this right now, later on we'll do more stuff, but sine can only be as big as 1 and as small as -1. You see, and then it starts getting bigger again. So sine has to be between -1 and 1. So sine can never be 5.4. The other way you could think of this is SOHCAHTOA. Sine is opposite over hypotenuse, and since hypotenuse is always the biggest side, there's no way this fraction can ever be bigger than 1. That's the second way you could do that. Okay, D, 135 is a quadrantal angle. Alright, well, I would totally understand because you don't need to know what a quadrantal angle is right now. But quadrantal angles are these angles on the x and y axis. Those 4 are considered the quadrantal angles. Those are the only places that trig functions are sometimes undefined. And 135 is, I don't know, it's in a quadrant. It's not on an axis. So that's why it's not a quadrantal angle. Okay, and then G says, your calculator says that theta is 69.07 degrees, 007 degrees. It asks you to round to the nearest tenths place. Well, how many decimal places is tenths?
1.
Okay, so even if it is a 0, if it's asking you to round to the nearest tenths place, you should technically still list 1 0. That's not a big deal, but it's good for you guys to hear it. So.
Thank you.
Okay, it seems like you guys wrapped up your questions right about the right time. Again, if you did not make part of your homework, check in your answers to the test review. Make sure that you do that, please. You may have also noticed below the solutions when you checked your answers that there is a second optional test review. So if you know that you need extra practice, that is a good way to go about that. And one last thing that I can offer you guys. It's completely optional. The optional thing I can offer you, I'm going to put them on the desk over there if you want them, is I have some extra copies of the quizzes, the non-makeup version ones. So let's say in 4.1 may be your weakness of the 3 sections. You are welcome to get a second copy of Form A or Form B if you would like. Or you could take Form A if you want to try it again with different looking questions. I say that, I only have Form B. But so I've got some Form B of quiz 4.1. I've also got 4.2. I still have Forms A and B. So if you would like another copy of Form A or another copy of Form B, or you would just like the other form for some extra practice, I will put those right here. I can't pass back the makeup form version. A and B are fine if you would like some extra practice there. And then finally, the 4.3 non-makeup versions, I've got some extra 4.3s, Form A's, and some Form B's. And if you don't want any of these, that is perfectly fine. But these are going to just be recycled anyway. And most years, there's quite a few students who do like to take 1 or 2 of these for some extra practice. Again, it's completely optional, so if you really only need to practice a few questions from one, that's fine too. It's not anything you have to turn in. But if it would benefit you for any of those, feel free to help yourself. They're over there.
Are we going to have a calculator on the test?
This one is calculator allowed, yes.
Okay.
And again, those just get thrown away and recycled, so if you get any use at all out of them, I'm happier about that than them just being trashed. So take what you want, if it'll help. But make sure you grab them now if you want them, because once my other classes get a chance to grab them too, there'll be less of them. They may run out of some.
As I turn stuff in, will we tell like, so we get like a CD? Or
I do, yeah.
Will we like add like a private caller email?
No, you don't need to.
Okay.
When you turn it in, Google Classroom sees it as being late because it's past the due date. I know it doesn't count late for you,
Okay.
but I get an email saying that someone heard something.
Okay, I just want to make sure it's like, I don't know, as I finish it, I'm just turn it in.
Okay, that's good. Yeah, if you guys have any of that late work, incomplete work that you're trying to do for some partial credit back, you just have to put it in Google Classroom. Google Classroom will email me and let me know that you turned it in. So. All right, it's getting close to that time, so I need my calculator back. Make sure you update your planner that you got a test on Monday.